Okay, we're going to go ahead and use Demar's theorem on this one here because we have a complex number raised to a power. Now, would we have to use Demar's theorem? No, we could take negative 1 plus I times negative 1 plus I times negative 1 plus I 8 times, and then we'd have to FOIL that out like 7 different times to be able to get an answer. I wouldn't recommend that because with the negative here and getting an I with I squareds, you're more than likely going to go ahead and make some mistakes in all that process. So the first thing you want to do is go ahead and take what you have right here as your complex number, and you want to go ahead and graph that. So that means we've got to go 1 to the left and 1 up. So we go 1 over, 1 up. Remember, we draw our triangles always going to the x-axis for a right angle, come out from the origin to where we were going. Now we need to figure out r and theta. So we can go negative 1 squared plus 1 squared equals r squared. And so we get root 2. Then we have to figure out our angle. Well, we know our opposite and our adjacent. Well, all we have to do then is just use tangent, because tangent deals with opposite and adjacent. Tangent equaling negative 1, that's one you're supposed to have memorized, and you know you're in the second quadrant. So when is tangent equal to negative 1 in the second quadrant? Well, that's 135 degrees. So Demar's theorem says you need to take your r value, which is at root 2, raise it to your exponent of 8 in this case. Then you need to go in brackets, cosine, take your angle, multiply it by your exponent of 8, and then you got to do plus I sine, and remember whatever angle you have after your cosine matches whatever angle you have after your sine. Well, let's see, this is just a 2 to the 1/2. 2 to the 1/2 raised to the 8th means we have to multiply those exponents because it's an exponent raised to an exponent. So we get 2 to the 4th. We multiply these together and we get 1,080 degrees for our angle. Wow, that's more than our once around the unit circle. So we'll simplify this down. 2 to the 4th is 16. All we have to do is take 180 and keep subtracting a full revolution until it gets to be between 0 and 360. So we subtract 1,080 minus 360 minus 360 and do that until we get down, in this case, it's to 0 degrees. So what we have here is our answer in trig form. However, we started out with the a plus bi form, the rectangular form, so that's how we're going to want to leave our answer. So we're going to go 16. Cosine of 0, you're supposed to know that. I sine of 0, sine of 0, you're supposed to know that. So now all we have to do is distribute through. We get 16. So if you're using or raising it to a power, you use Demar's theorem like this one here. However, on the next one, we're going to want to go ahead and try to solve it for x. To do that, we got to get x by itself. So now we'd have to take that to the other side. Now we have to take our square root. Whenever you are taking roots of a complex number, that's when you use that other ugly looking formula. The first thing you would want to do is once you have x all by itself, you want to go ahead and graph that complex number. So we're going to go 0 left and right, and we're going to drop down 36 in the I direction. So that means we're just 36 straight down here on our negative y-axis. Once again, r is your distance away from the origin. Well, we're 36 away because you're 36 down, so it's r is 36, and remember r is always positive. Your angle, well, we're going all the way from here, all the way around to the negative x-axis, which you should remember is 100 or 270 degrees. Or if you wanted to use 3 pi over 2, you could. Does not make a difference. We do have to make one adjustment in your formula, though. Now, n is the root we're taking, and we're taking the second root. And remember, k is always starting at 0, going up to one number less than n. So in this case, it's just 0 and 1. If n was 4, you'd have 0, 1, 2, and 3. Now we're going to go ahead and plug stuff into that messy formula. We need to go the nth root, or the second root of r. Then we have to go cosine, and then we get a big ugly angle. We have to go our theta, which is 270 degrees, plus 360 degrees k over 2. Now there should be a degree symbol right here after the 360. Now, if you had this in 3 pi over 2, you would have to go ahead and replace this 360 with a 3 pi or a 2 pi. So that's the change you have to do if you're dealing with degrees, is change your 360 to a 2 pi. Now, whatever we have after our sign here, we go plus I sine, is always identical to this here. Now, we can simplify this a little bit before we work it out. We know the square root, second root of 36 is 6. In this case, I can simplify this fraction. Sometimes this fraction won't simplify much. But I'm going to take the 270 over the 2 and the 360 over the 2, and I get this here. And once again, whatever's after the sine matches whatever's after the cosine. Now, at this point, I can start plugging in my different values of k. I'll start off with k being 0. So I'm going to plug in 0 for my k values. It's going to do nothing to the number in front. Plug in 0 for k here. 0 times 180 is 0, so I just have that 135. And then whatever I have after the sign is identical. So this is my answer in trig form. Then I'm going to go on and do k be equaling 1. So I'm going to still have that 6 in front. K equaling 1. 1 times 180 is 180. 180 plus 135 is an angle of a 315. Then whatever I have after my sine's identical to whatever is after the cosine. So I have my two answers right here in trig form. However, we did not start out in trig form, so I don't want to leave my answers like this. We started out in the a plus bi form. So all I want to do then to get rid of the trig form back into the a plus bi form is basically distribute through after I go ahead and figure out what each one of these values is. Cosine of 3, or not 3, but a 135 you're supposed to have memorized. Sine of 135 you're supposed to have memorized. Now all you have to do is distribute through that 6. So you get a negative 6 root 2 over 2, which reduces down to a negative 3 root 2. Distribute it through to what's after the plus sign. So we get our answer in a plus bi form. And then we're going to do the same thing down here, because cosine of 315, sine of 315, you're supposed to have those memorized. We distribute through, and then we get our two answers over here in a plus bi form. So that's how we go about taking roots of complex numbers.